Good afternoon, everyone, especially my lecturer in UBN. Okay, my name is Leong Shija. Today is my first title on the presenting this detection of fastener loosening in simple lap joint based on ultrasonic wavefield imaging. So the meaning of the fastener, I think most of you will know. Fastener is mean the combination of the screw, nuts, and washer in a simple way of the imaging. So we do it in experimentally and also through computer processing of the image. So ultrasonic wavefield imaging is a type of the method to obtain the data through the experiment. So this is just obtaining data through this UWI, and then I will discuss later on how I process the data and get the damage evaluation image. Okay, so first of all, let me start from the problem background. So, because my research is on the lap joint, right? So, we look at the real life problem now. There are a lot of the joint in the real life. So, let's see from the first one, the pipeline in the oil and gas industry are using a lot of the joint in joining the pipe all together. Then on the wind tower, wind tunnel blade also, because wind tunnel is a very huge structure. They are combining of many different kind of the blade. So a lot of the screw required to join the wind blade to the wind tower. Same goes to the bridge. Bridge also require a lot of the joining. They use the gusset plate and so joining the beam and also do the gusset plate together so that the whole structure have to be set. So in aircraft there is also rivet and joining the aircraft skin with the spar and also the stringer. So my focus today is on the screw and nuts. So at once like the rivet, also welding is not my focus, and then we will just look at the simple one, which is screw and nuts. So okay, there are actually a lot of improvement on the current technology. So they use the simulation advancement such as finite element to check how is the stress. Also, they are also using two nuts to make sure the screw is very tightened. Also, it is using glue also. So they actually currently have a lot of improvement. But is it really safe? So let's see. Okay, structure failure still occur. Let's see one of the example. This example is on the Mississippi River in the USA. They have been collapsed on 2007. Why is it so? Okay, it is because due to the fastener gusset plate already failure. So, okay, let's see. In aerospace field, there is also the problem due to the four-fielded boat. This problem causing the 767 wing has been ripped off. So we are not sure, is it the boat is already just fly off during the flying, or is it already loosening on the ground during the ground station? So okay, a background study on from the Korea, it stated that in Korea, 33.3% from the research stating that the failure is due to the boat defect. From the boat defect, 58.1% is due to loosening. Okay, actually, fastener, every fastener normally it only has a 15% of contact. 85% of it is actually have a gap on that. This will causing the movement. So if any shock or vibration have initiate, it will causing the very strong vibration and causing it looseness. Actually, currently there are many of existing methods on how to detect is it the screw is already loosening or tightened. Actually, for example, resonance frequency shift method and also ultrasonic time of flight, ultrasonic velocity ratio method. This all method basically using a device and then just put at the screw and then generate the ultrasonic wavefield onto the certain screw, and this have to do one by one every screw. So if you want to do a lot of checking of every screw, then it's very laborious work. So this type of existing method is actually, I would like to say, is very tired. So, okay, let's see. Other method, they also using piezoelectric impedance, then have to permanently install on the Aries fastener to measure the mechanical impedance and then calculate back the fastener preload. Preload is meant by the tension in a certain fastener. So if it is very tightened, then it's a high preload value. So if loosened, then less preload value. Okay, so other type of methods such as optimal time domain reflectometry method, they are using optical fiber connecting to the airy bolt and nuts. Then when we generate light over the optical fiber, if it is loosened, then the optical fiber will be bended. So if it's bended, then the light will be less. So this type of method is the existing method lah. Okay. So okay, I would like to say currently existing method is not very good because it needs a lot of manual inspection by using a lot of equipment. Need to put at here a manual wire, and also this type of method require a baseline data, which means if the bridge is on 50 years ago, 100 years ago, we don't have the baseline data. So how? Okay, we need a baseline data using the existing method. So my research will using ultrasonic wavefield imaging, which I use a laser and then the scanning on the plate, and then just getting the data and I processing it. If it is depends on how you want to process. If a very advanced method will provide a single and video image with damage highlighted. Okay, this is a flowchart. So this is what my experiment. This is a simple lab joint over the plate, stainless steel plate, and then I have 5 bolt, and the second bolt from the left is the looser one. I purposely loosen it, and then I check is it my method can be used, and check no, the second one is loosened. The other 4 I tighten with torque wrench. Okay, so I scan the plate, I get the data, arrangement. We have SYT. Okay, you see, SYT means time. S is horizontal, Y is vertical, T is time. So what I get the data is in SPY matrix, and I need to arrangement to get SYT. Okay, so that and I can see how is it the video in the time series. If it's using fast Fourier transform, I can know the frequency domain. Okay, simple way. Okay, this plate, the looser one, second left, and then upper 100 mm, we have a sensor bonded to check the wavefield generation. Okay, this video. Okay, basically this is a UWI video. So the upper plate, we actually can see the wavefield is starting from above, going down, and then in the middle is actually the bolt in the middle. So this method you can see is not very clear, right? Because we cannot see anything that we want, right? So at 23.8 seconds you can see actually there is a 5 hole, because the 5 hole is means the bolt and nuts in the 5 bolt and nuts, right? So this type of method is not very clear. So we move on. This is the time series. So we move on. We do the frequency series by using a fast Fourier transform. Okay, we can get this one. This one is basically we can see is 5 region of interest I have been circled. So the color difference is still not very good, but we can at least we can see at the second from the left. Maybe the slide is not quite good. Okay, we can see second from the left. The color difference is a bit high already compared to the other 4. Okay, so we use the contrast maximization method, and then we using this formula. Okay, this formula means we have the 5 bolts, right? So okay, the second bolt is purposely I loosen it. So it means the first bolt, the contrast difference the first boat minus the second boat contrast difference, okay, we get this value. And then the third one minus the second contrast value, okay, get one value. Same goes to the fourth and fifth boat. Then when I get this one is just a one frequency only. So we have already four contrast different value. Then we calculate the mean value. One mean value for one frequency data. Then we have a lot of frequency because 250 frequency. Over the 200 frequency, and then we get the minimum one. Why we want to get the minimum one? Okay, contrast maximization. We use minimum one to know the comparing with each of the fastener has at least this type of value. So if it is more, that means better, good, also can look better lah. Okay. In conclusion, okay, joint are very critical element of aero-mechanical structure. If it is loosening, it will cause a lot of problem, a lot of damage, and then the assessing method is already generally suffer because if you want to go on the high place, go to the wind tower, you have to climb to a very high and then just want to check that certain boat is loosened or not. So if you're using a lot of permanent installation like the transducer, it will cause a lot of problems. If it is, you need to consider the environment degradation. Okay, so if it is need baseline data, you need to know this boat is this baseline data. If it have thousands of boats, then you have to confirm this data is for this boat. So it's very hard. So for my product, UWI imaging system, we can know the inspection don't need to be very many people. Just have to one laser and then just one computer. We can inspect it already. So I think that's all from me. Thank you.